Alright, welcome guys. So this is for the ecology project, and for those of you who are doing food webs and energy pyramids and the flow of energy through the ecosystem. And I kind of let off talking about this today, but I just wanted to, I want to touch on it a little bit at the end. That when we make decisions for the environment or the ecology of the planet, most of the time we're not making decisions based on what's best for that system. Most of the time we're making decisions based on some societal value or the economy. And there's only a very small area where we make these decisions, it benefits all three. Okay, and I want to come back to that at the end, but I just wanted to, again, lead off with that idea so you're thinking about it. I'm going to skip ahead in the PowerPoint here. Okay, food webs. Okay, now in ecology, we do a lot of modeling. You got to remember these are very complex systems. Okay, so a lot of computer modeling of this. The most simplistic model we probably have is the food chain and the food web. Food chain being the simplest, food web being the second most simple. Okay, and a food web is a model that shows a complex network of feeding relationships within an ecosystem. Okay, and so the idea I want to convey here is this idea of trophic level. Okay, there's these different levels in the system, and energy travels upward in the system. Now the bottom of the system is what we call the primary producers, okay, the autotrophs, or the plants. Okay? All of the energy that enters the system comes in through photosynthesis. And not only the energy, but these biochemical molecules, okay, the plants are making and putting together for the first time. Things like amino acids and DNA and RNA and proteins, okay, simple sugars. Okay, that's the plants are making this. And so not only is energy traveling through this system, but also molecules, these biochemical molecules are being passed organism to organism and are recycled. Okay, so just think about that as you see this. Okay, after the primary producers, or the plants, we have what are called the primary consumers. And these are organisms that only eat plants. So if you look at the example here, that would be the mouse and the pine borer. Okay, they are the ones that are eating plants. Okay, I'm going to talk about energy loss in a second. Okay, the secondary consumers are things that eat those two things. Okay, so that's the golden-crowned kinglet, the salamander, and the snake. Right, and then we have the tertiary consumers, and those are the things that eat the secondary consumers. So that would be the looks like the red-tailed hawk there. Okay, so it travels upwards in this system from primary producer to primary consumer to secondary consumer to tertiary consumer. And you can actually have levels above that also in a complex system. Now, this is where it gets a little sticky, and depending on the system you look at, we can define this differently. But that's the decomposers. Decomposers kind of eat from all levels. Okay, so plants will be decomposed, primary consumers, secondary, and tertiary. So you can think about this as, on the side of the system, okay, that it's not really part of the trophic system, and that, it's kind of everything will be decomposed. Or you can think about this at each level, that decomposers are found at each level of the trophic system. And it's both. It's not either or. It's just how you want to think about it. Okay, so don't forget the decomposers in your systems, because they are integral. They recycle, they get out the last bits of energy out of this system, and also they recycle a lot of these biochemical molecules we've talked about. Food chains. Food chains are the more simple model. I didn't lead off with them, but they show single feeding relationships. Something I forgot to mention before is when we're drawing this, the arrow always points to where the energy and the molecules are going. Okay, so the plant, okay, it's going to the energy and molecules are going to the herbivore and then the carnivore, okay, and end up through the chain. When students miss this on the test, oftentimes they draw the arrows pointing in the wrong direction. Okay, so just remember the arrow points to where the energy and matter are flowing to or going to. Okay, so food chain, just a single feeding relationship, and then you take a bunch of food chains in the same system, and that would be your food web. Okay, energy pyramids. Okay, this is a diagram that compares energy used by the producers, primary consumers, and other trophic levels. Okay, and so we can draw this pyramid. And the reason why it's a pyramid is we want to show that at the bottom levels of the system, there's more energy. It has a broader base of energy. And as you move up, there is less energy available. Okay, so think about that. In fact, I talked about this in class, 90% of the energy is lost between trophic levels. And it's given off as heat. It's given off as heat because these organisms are doing work. Okay, so plants are growing. Okay, they're bringing waters to their leaves. They are producing chemicals to fight off predators. Okay, things like that. Okay, the primary consumers, they have to move around to gather the plants. They have to try to elude their carnivore predators. Okay, so most of the energy that's in each trophic level, it's lost. It's lost in the form of heat to the environment. Okay, so that's a very important concept. And because of this, okay, so here's that loss from 1,000 to 110 and 1. And because of this, we can talk about things like the numbers. Okay, and why don't we have more owls than voles or rodents? Okay, and the reason for that is because the energy isn't there to support that many. Okay, and so when you get in these kind of lopsided numbers, when you have more of something, you experience a very quick and rapid die-off to get things back in order. So let's go back to that kind of idea that humans make bad choices for the environment. Okay, so when we do things like deforestation, we remove the trees. Okay, remember, the animals that rely on that, they don't immediately die with the plants. It's not like the trees are falling on them. Okay, but they have to move and try to compete for those resources elsewhere. And so these energy pyramids get out of whack. You can have more primary consumers than you have plants. And that has a twofold increase in that those herbivores are going to eat more of the plants. Okay, so you're going to get even a decrease of that bottom layer, and then things are going to die off. And so things can get out of whack very, very quickly, and you can move very quickly towards a system collapse. And that's in fact what we're seeing a lot today, is whole system collapse. And when you hear system collapse, you hear this on the news or something. It doesn't mean that everything is dying. It means that a lot of things might die and go extinct, but you make the system more simple and less complex. And complexity in these systems is really important. It gives it vitality. It gives it resiliency. Okay, so if you remove one herbivore from a system, the carnivores can maybe find a second herbivore to eat to replace it. Okay, but if you remove too many herbivores, eventually those carnivores aren't going to be able to find any food, or it's food that's not available to them. And so the system gets more and more simple. Okay, until you're left basically with just simple plants and maybe a very simple first level, which is not what we want to see in the environment. We value complex systems because they are of value to us. Okay, sitting atop these food webs, we rely on a complex system. All right, so think about this. Think about if the only thing in the supermarket was some type of vegetables, and then like algae protein or something like that. That was you couldn't buy steaks anymore, or you couldn't buy chicken, okay, because the environment can't support those animals anymore. So we have texturized vegetable protein or something. And some places, we're getting very close to this. When you hear about like 3D printing meat and stuff, it's not because we want to eat that stuff. It's because we're getting to the point where that's getting what's available, and it's a little scary. All right, so that's my talk. So just remember about the energy flow, these energy pyramids, and the food webs, and that they're related to each other. Okay, these aren't separate concepts; they are related. All right, thank you guys, and good luck.